Solid Edge with synchronous technology allows us to rapidly create initial designs. That's the beauty of direct modelling. But pure direct modelling can fall short when it comes to developing that same design. Not the case with synchronous technology. Let's take a look at the precise parametric control on offer while we progress our spring clip concept. First, let's bring in our spring clip and assemble it with the parts it was intended for. Clip to the base, and the USB block it needs to hold. The first precise change we need to make is to close up this gap between the top of the USB block and the spring clip. In most any other CAD system, you'd have to make this change at the 2D sketch level with sketch relations. In Solid Edge, we can simply relate faces in 3D instead. Easy. Looking at the back, I noticed the tabs on the top are not quite square with the top face. No problem, a couple more 3D relations will fix this. For the side faces of the tabs, making them perpendicular to the top. And for the top faces, making them perpendicular to the side. And notice how both tabs are being updated here. That's the intelligence of synchronous technology. Let's start detailing this model, and of course dimensions are key. Solid Edge has two main ways to dimension. The first is like most any other CAD system, in 2D when creating a sketch for a feature, but the second, which you see here, is unlike most any other CAD system, and much more intuitive. Just dimension the 3D model directly. We can leave this floating so that we still have the flexibility for further changes, or lock it down to be precise. We'll lock this down and we'll add another one for the flange width. We'll dimension these top tabs next, and look closely at the precise control that's provided. These green arrows allow us to control the direction of the change, which side moves and which side stays put, or even a symmetrical change if we wish. We'll speed through adding the other required dimensions using the same technique, and for your information, the red dimensions are the ones we've locked down, and the blue ones are the ones we've left floating. Overall, notice how easy they are for someone else to understand. Great for reviews. Oh, and of course, we're not just talking linear dimensions, let's detail the angle here too. We should finish working on the other end of the clip. Another 3D relation will do the trick to move and match the angle of this piece. And we can use what's called the steering wheel to drive a synchronous drag and snap into place here. And let's make sure that the whole thing is assembled centrally. Next up is the retaining clip that needs to slot inside the groove of the USB block. Once again, an easy face relation, or steering wheel, drag and snap can be used. Whatever's easier. Perfect. One last subassembly to bring in, an inline fuse. The purpose of the top tabs are to support this, so we need to make sure it'll fit tightly into place. So let's make some more precise direct edits. Now I know the wire diameter is less than 3mm, so what we can do is drag the steering wheel to create a 3mm offset before dragging and snapping the tab itself. This leaves us with a 3mm gap, precisely how we want it. Let's drag this section in two, up against the fuse. Something worth noting is that for sheet metal dimensional control, we can design to either the outside or inside. It doesn't matter which dimension we change, be it inside or outside. Solid Edge will always take into consideration the material thickness. Design complete, and of course it doesn't stop there. We can take this same all-in-one concept to final model into a manufacturing drawing. First of all, let's create a custom view of the assembly so that all aspects of the part can be seen. Let's have that shaded, and a few views of just the clip. And remember the 3D dimensions we added to the part? Look how quick we can bring those dimensions into this view. So in summary, we've seen how Solid Edge with synchronous technology provides rapid direct modelling, but importantly with precise parametric control, relating faces, dimensioning, detailed drag and snaps, all in 3D, no sketch work in sight. Fast and easy, but most importantly accurate. Solid Edge, design better.